Introducing the Snap-on Low Amps Probe, an exclusive new diagnostic product designed for the Snap-on Counselor 2 digital oscilloscope. The Snap-on Low Amps Probe gives you a fast new way to diagnose dynamic system problems. You can monitor the primary ignition coil current on a distributorless ignition system. Check the integrity of an ignition control module, find defective drivers, and test the operation of fuel injectors and other actuators. The innovative, non-invasive technology of the Low Amps Probe allows you to measure low levels of electrical current in a fast, safe, convenient way. It's easy to get the diagnostic information you need to isolate problems in electrical devices and circuits. In this video user's manual, you'll see why you should use the Low Amps Probe when faced with certain engine or system problems, how to connect and use the Low Amps Probe, how to display the test results, and how to read the diagnostic information in the waveform to find performance problems. You'll find complete information on using the Snap-on Low Amps Probe and interpreting the test patterns in a special section of the User's Manual for the Snap-on Counselor 2. The Snap-on Counselor 2 User's Manual offers detailed instructions for using the Counselor 2 digital oscilloscope and procedures for diagnostic testing. Why measure low levels of amperage? On modern vehicles, it's difficult to get to the source of many performance problems caused by malfunctioning circuits, drivers, or other actuators. The current level is so low, it's hard to pick up. Environmentally protected connections pose another challenge. You don't want to break into the circuit because the problem you're testing for may disappear when you tamper with the system environment. Non-intrusive testing overcomes all of these obstacles. You can't use voltage information to determine current flow in a circuit. With an amperage test, you have an additional piece of diagnostic information that helps you decide how to service a vehicle. With the Snap-on Low Amps Probe, you can test the integrity and continuity of electrical circuits simply by accessing the supply or ground wire. The Low Amps Probe measures alternating current, pulsating current, and direct current flow up to 10 amps with frequencies up to 5,000 Hz. You can test for open circuits, shorts, current flow problems, and sources of interference like poor connections, even from a remote location on a wire. Proper use of the Low Amps Probe is critical to your safety and obtaining reliable test results. Always observe standard safety procedures when you are conducting a diagnostic test. Always wear safety goggles. Be sure the garage is properly ventilated and drive wheels are blocked. Set the vehicle's parking brake and place the gear selector in neutral or park. Be sure to keep your clothing, hands, and other pieces of equipment safely out of the reach of any moving engine parts. Do not allow the probe to come in contact with moving belts or parts. Never use the Snap-on Low Amps Probe to measure current in high voltage circuits such as the secondary ignition circuit. Do not drop the probe or allow the jaws of the clamp to snap shut. Like other auxiliary probes for the Counselor 2, the Low Amps Probe attaches directly to the auxiliary lead connector. With the engine turned off, attach the white lead to the battery's positive terminal. Attach the black lead or ground to the battery's negative terminal. The primary lead goes to the negative side of the coil. The number 1 inductive pickup lead goes over the spark plug wire. The capacitive pickup clamps onto the ignition coil wire, or an integral coil pickup adapter attaches to an integral ignition coil, such as a General Motors high-energy ignition coil. Use the DI assembly when you are testing a vehicle with distributorless ignition. Connecting these leads is not necessary, but with them you will have access to more screens, functions, and signal trigger source options. And there may be times when you want to access or display another waveform for comparison. Before you begin each test, zero the low amps probe by turning the zero knob until the volts display on the LabScope waveform screen is 0. The LabScope screen is in the diagnostic waveform menu. Clamp the probe around the supply wire or the ground wire in the circuit you want to test. The arrow should be pointing in the direction of current flow. Now you can activate the circuit. The probe will sense current in the wire and generate a voltage signal in proportion to the current, 1 volt output for each amp sensed. The probe is sensitive to temperature changes and may occasionally need to be re-zeroed. At times, you'll want to open a wire harness to access a single wire and place the jaws around that wire. You may need a wiring schematic to find the right wire in the harness, although you can often find it simply by hunting for it. The advantages of using a wiring schematic are that you can see the layout of the entire circuit, where terminals or pins are located, and the path of the supply voltage, ground, and signal return. You can also gain an understanding of how color codes and other identifying marks are used. Most of the time you'll want to display a low amps waveform on the LabScope waveform screen in the diagnostic waveform menu. The LabScope waveform screen gives you the most flexibility in manipulating the waveform for better viewing and additional detail that will help you spot problems in the pattern. You can also view a low amps waveform on the vacuum waveform screen or power balance waveform screen when you want to look at its relationship to cylinder firing. This is especially helpful when you're checking the low amps waveform for a specific point that compares with cylinder firing, such as the start of current flow, a change in the waveform indicating electrical or mechanical activity, or a reduction in current flow. Be sure the engine information is correct for the vehicle you're going to test. If an RPM reading is required for an engine and the distributorless ignition lead set is not connected, enter 2 for 2 cycle. If the DI lead set is connected, enter 4 for 4 cycle. The waveform may have a tendency to drift off the screen. To stabilize it, synchronize it with another engine signal or the signal itself. Select the appropriate trigger source from the list of options. When you are testing an engine with distributorless ignition and you have trouble getting a stable pattern, disconnect the test leads to the spark plug wires and connect the number 1 pickup to the spark plug wire from a different coil pack. Be sure to adjust the firing order to accommodate the change. A low amps waveform is analyzed in the same way a voltage waveform is analyzed. Each amp that's sensed by the probe is displayed as 1 volt. The volts display is the average amperage, an important point to remember, with the current turning on and off at some duty cycle. Use the cursors to get an accurate measurement of amperage. If the waveform is too large or too small, adjust the volts and time ranges until you have an appropriate pattern displayed. If the amplitude is more than 3 times larger than the volts per division range, the volts display will overrange. To correct this situation, increase the volts range or use the cursors to measure the waveform. If the waveform appears to be upside down, reverse the probe's direction on the wire or use the signal invert function to turn it over. Use the grid and cursors to measure portions of the waveform such as current level, pulse width, or pulse period, and then check your test findings against a specification. Remember, if the amperage level is more than 10 amps or the pulse frequency is greater than 5000 Hz, the waveform that's displayed will not be accurate. As with other waveforms, a low amps waveform may be stored in memory for future reference or printed for a permanent record. You'll get the most diagnostic information from the low amps test if you understand the system activities that are displayed in the waveform. You may need to refer to a technical diagnostic manual for information about the system you are testing and its characteristics. The Counselor 2 User's Manual and the video Diagnostic Test Pattern Interpretation will help you understand more about automotive systems and their corresponding waveforms. Let's look at the diagnostic information you'll get from 4 tests with the low amps probe. The techniques for testing and analyzing the waveforms presented here will help you perform additional tests with the low amps probe. The tests evaluate the integrity of the primary ignition circuit of an engine with distributorless ignition, the performance of a sequential fuel injection system, the integrity of a fuel pump relay, and the cause of a failed quad driver inside an ECM. Until now, you could not use the Snap-on Counselor 2 digital oscilloscope to test the primary circuit of an engine with distributorless ignition. The low amps probe gives you access to that diagnostic information. Attach the low amps probe around the power feed wire to the ignition module. Let's review the activities that generate a primary waveform. When the primary circuit is turned on, a low level of current starts flowing from the battery into the primary windings of the ignition coils. As current passes through the winding, a magnetic field builds around both the primary and secondary windings. The waveform slopes upward while current is flowing. The upward slope of the waveform is the rise time. It's the time required for the current to reach its maximum level. The rise time depends on the size of the wire in the coil and the number of windings. If the circuit has a current limiting device, the waveform will flatten out at a specific amperage level or will peak at a maximum level and then fall abruptly and flatten out at a lower current level until the current flow stops. In either case, the final current drop signals the end of the dwell period. At a specific point, a primary triggering device turns the current off, inducing a voltage in the secondary winding that's high enough to fire the cylinder. If you're viewing the waveform on the LabScope screen, select the number 1 trigger source to help you identify the cylinders. You can also view the primary waveform on the vacuum waveform screen or the power balance screen, where it's easy to identify the cylinders. If you display the low amps waveform on the vacuum waveform or power balance screen, be sure to turn off the error message. Let's take a look at some waveforms that indicate a problem. The peak is missing when a coil is not drawing current for reasons like an open coil winding. A shorted coil winding will have a peak at an amplitude or rise time that's different from the rest. At times, you'll want to use the LabScope's dual waveform function to view a waveform's relationship to another waveform, such as a synchronized signal from the camshaft sensor, which will signal fuel delivery. To test a sequential fuel injection system, attach the low amps probe to the power feed wire for all the fuel injectors to test the entire system. You can attach the probe to the power wire for each injector to test individual injectors. An engine control module completes the electrical path to the fuel injectors by switching a low level of current on and off at appropriate times. You must understand the characteristics of the system you're testing to get meaningful information from a waveform. This fuel injector has a current limiting device. This one does not. The fuel injector is a solenoid with windings and a movable solid core. Magnetic fields expand and collapse along the windings, putting the pintle into motion. This is how electrical energy converts into mechanical activity, opening the fuel injectors. The low amps waveform gives you information about when this mechanical activity happens, diagnostic information that you can't get from a voltage waveform. The dip in the slope of the rise time is the point when the pintle starts to move when the fuel injectors open. For some applications, the pintle movement is so subtle it's hard to see any change in the waveform. The ECM synchronizes the fuel injector signal to a reference signal from the camshaft. Use the dual waveform function of the lab scope to view the phase relationship between the two signals. Use the vacuum waveform screen to see the effects of current changes in relation to cylinder firing. When you're using the vacuum waveform screen, note that the pulse that occurs when a fuel injector is energized usually precedes the cylinder's vacuum event. Use the vacuum event numbers on the bottom of the screen to identify the cylinders. Here, the fuel injector for the number 1 cylinder is not working. To test the performance of a fuel pump relay, attach the low amps probe to the high current power feed wire to the relay, or attach the probe to the wire between the relay and the pump. This waveform is typical for a direct current motor with internal brushes that come into contact with a segmented commutator bar connected to the windings. The oscillations represent the expansions and contractions of the magnetic fields, which causes the armature to rotate. A faulty connection in the circuit creates an erratic waveform pattern. A low amps probe is very useful when you need to test a GM quad driver, which is ground side controlled. You can't determine how much current is flowing through a circuit from a voltage test. The maximum current level of this solenoid circuit should be no more than 0.75 amps. If the current reading is above this level, there is a problem in the driver or circuit, such as a short. If the problem is an intermittent one, let the engine idle for at least 2 minutes to be sure the component is at normal operating temperatures before conducting the test. To test the component or circuit, turn off the ignition switch and disconnect the wire harness at the ECM. Use a jumper wire to connect the circuit you want to test to ground. Attach the low amps probe to the jumper wire or a circuit wire. Now, turn the ignition on and check the amperage level. If it is higher than 0.75 amps, the circuit or component is damaged. The new Snap-on low amps probe gives you a fast new way to diagnose a variety of dynamic engine problems. The Snap-on low amps probe provides diagnostic information that can be very useful when servicing a vehicle. Do not rely on test results that are erratic, questionable, or obviously wrong. Misdiagnosis may lead to improper repairs or adjustment, which could damage the vehicle or your equipment, or make the vehicle unsafe to operate. When you question the test results, first check the test lead connections and verify the accuracy of the engine information. Be sure you are performing a test correctly. If you still have doubts about the test results, ask your Snap-on representative for assistance.